All right. Hello to Chris Sears and Navigating College Math. That's a new channel I need to subscribe to for sure that I was not aware of. I do, Chris, if you're in Slack, not Slack, sorry, Discord, I tend to look at the live chat supporters channel in Discord, although the YouTube chat is, of course, welcome. All right, so I'm just getting myself set up here. Let me erase the whiteboard. Side. Okay, good shape there. Simon and Kathy and Guy. Oh, hello, Guy. So, I'm very happy. Okay, whoops. Managing moderators can support your channel even more ways. These users have same capability as standard moderators, so they can manage block words and change chat modes in live. Oh, that's fascinating. So there's some new live features, which is great. So if all of you, anybody who's watching, Guy is the only one who I haven't seen in a while. And I don't, maybe is it Guy or Guy? Please let me know. And are you in Discord? Because under supporters, live chat would be a better place to type your messages. And let me. And fans are running now, which I will turn off. Somebody will remind me, and I got to make sure I'm recording on the cameras and recording the disc and all the usual stuff. Let me go to here. So the section that I'm redoing today is the very last one. I will say there's a small chance that after I finish this, I will want to go back and redo some of the earlier ones, only because before I started recording to the SD cards on the camera as backup, there are some kind of glitchy parts of the footage. I'm gonna look at it. I think maybe the glitchy parts are tolerable and I'll just leave them. But all of my experiments to try to use like fancy AI and other kinds of interpolation video tools to clean up some of the stuttering in the earlier videos, the earlier recordings, I'm not able to. Now, it looks like there are two sections left to do, objects and arrays, but there are not, because I already did arrays and things are in a slightly different order now. So I do need to do, let's see what's here. Ooh, okay, yeah. Ugh. Interesting. This was definitely done. These were done much later, I would think. Let me look at these. I mean, not that I'm still gonna redo them, but am I really gonna do all of this? Okay. I mean, the part 1 and part 2 stuff is less. Let me go to YouTube here. Let me just sort of see what's going on.
Okay, this is going to be a little bit of a tough. Here we are. We're going to begin talking about object-oriented programming and the theory of object-oriented programming. And I'm going to remake this video later, but it's just going to live with it right now. So we're looking at this video. We're going to get into the nitty-gritty and what's involved. We're looking at implementation, what it means to write class, to use objects, and multiple objects later. We raise objects. There's so much to come forward. But to start with, to begin with, we can take a deep breath and just understand what are we trying to do with object-oriented programming. Well, okay. So in one sense, we're trying to understand a computer program in the way that we think somewhat about it. And we've got one way over here. We have this ball bouncing around the screen. And we can say I've actually written this program already using object-oriented programming. This is where we want to get to understand all of the pieces here by the end of this set of videos. So we can start with this view. What we're looking at here is we're seeing the manifestation, an instance of a ball object moving around the screen. What is a ball object? What is the innovation of object-oriented programming? So our programs so far have looked like this. We have setup. We have draw. Right? That is the sort of framework for the flow of our program. What else do we have? We have a bunch of variables up here. We can think of that as the data of a program. This is the data of a program. The X, the Y, the X speed, the Y speed, the color, the film, blah, blah, blah. We have the functionality. What are the things that are happening? Something's moving, something's checking its edges, it's being displayed, it's exploding, it's doing stuff, it's dancing, right? We try to dance ball. But next time. We have functionality. Move. I think I actually call it update. Updating this, we have maybe a function called display. Display ball we had in one of our most recent programs. We have functionality. What object-oriented programming does first is it says, okay, we have data, and we have functionality. We want to put those things together. We want to have an object that wraps the data for an entity, the functionality for an entity all together. What is that entity? Well, that's what's up to you. Conceptually, how do you organize the pieces of your program? If we were to make this call, maybe there would be some paddles. So there would be paddle objects and have ball objects. Maybe there would be something we need to sort of manage the whole game, score the player games. Maybe we have a game manager object that has that data associated with it. So we're looking to take data and functionality and put them together. We can think of this, one way to start thinking about this is actually to think about you yourself, or me, myself, as an object. We're an object living in our world. What do we have? We have data. For a human object, a human has data. Maybe a human has a height, an eye color,
So
personality.
what's a good example for me to start with that's not a human?
Whatever. As you can see, that there's lots of data that can be associated to describe certain aspects of a human being. A human being can also do things. There might be functionality. For example, I can eat. I'm actually wait. I'm really putting out time to get lunch. I walked down the I really should stop this video, but about 4 minutes, we're almost to the end. I can eat. I can sleep. I could run, right? There is data and functionality associated with a human. What we need to package all those things up into an object so that we can add human beings to our processing sketch. That might be a little bit ambitious, but we can get there eventually. So this is the theory behind what we're doing. You start to see the syntax of this. Now, how does processing know what to do when to make a ball object, or what to do when to update a ball object? Well, there's actually a sort of secret little tab here, which I'll just flip to real quick. Look at this. This is all the code for the ball object. This is like a mini program to describe everything that's in the ball. There's variables in the ball. There's functions in the ball. That's what we're going to get to in future videos. How do we write that? But we should notice something about this that's pretty important. This is going to be very important to the next set of videos that we're about to look at, the examples we're about to make. There is this idea here. What have I written up on the board here? I have not put a human being on the board. There is no human being here. What I have done is given you a template for making a human. This is the cookie cutter. The cutter to cut a human being out of the stuff that make a human being, right? But this is the concept of what it means to be a human being. Then there is right here the human being, him or herself, right? I have an instance of a human being object. I am a human being. I am human. Don't feel whatever. Anyway, this is what it means to be a human being. I know things that going on. This is actually quite important. We have this thing in Crossing which is called a class. A class we can think of as the template, right? A cookie cutter is a template for making a cookie. A cookie, which I've eaten young, is the cookie itself. This is quite important. We need to write the class. We need to write the template for what it is to make a ball, so that we can have an actual instance of a ball object in our program. So the class is the template. The object
Flowers.
is the thing.
That's a really good
This is
one.
where we're going. And I think in the next video, if I outline correctly, what we're going to do is learn how to write a class. We're going to learn how to write a class.
Can I use that? Flowers? I love that. Like number of petals, color, the functionality is grow.
The things don't exist unless we use them. The template is what defines what it is to be a ball bouncing around the screen process. So this is what we're looking to do. This is what we're hoping to do in this next set of videos. Think about this. I don't really have an exercise for this. Take something you've done in the processing sketch and try to write as a list. Just write for yourself what is the data associated with it. What are the functions associated with it. So design your template out. So you can use pencil and paper. And if you want, you can even sort of imagine what it would be to type the program like this without knowing what each piece of the syntax does. You can look at this and how to the structure. Okay. So in the next video, we will actually look at writing class itself.
Okay. Ooh, I want to watch this. Let's build. Oh, it's Andrei Karpathy building GPT from scratch in code spelled out. Wow. Well, that's 2 hours. I don't have time for that. 1 million views.
So by now you've probably heard of ChatGPT. It has taken the world and AI communities from. And it is a system that allows you to interact with an AI and give it text-based tasks. So for example, we can ask it on top of the current sort of running stream of pictures. And this gives us what possible. And then we can return that. Now, one thing here is you see on law. So first let's get started with preliminary software. And then aggregate value and content. Then here in the legend file, I'm creating a head in the constructor employee itself to head. And the head size I'm going to keep as the same and in just for now. And then here.
I guess I'm not subscribed to. Okay. All right. I got distracted. All right. Okay. I think a plant. Yeah. Is it Guy or Guy? I want to make sure I'm saying your name correctly. The reason why I like flowers as opposed to plant is because it evokes more color and more kind of design ideas that somebody watching who's a designer might think about. Where are you, Amr? I forgot. Like the normal word guy. Okay. And Amr, where are you? It must be late time zone for you. And I'm enjoying this like just informal socializing, but I've got to get started. I should really get started. So just to be clear, I don't know how much I'm going to do, but I thought maybe let me record a little bit tonight, even if it's just for an hour. Sometimes it's best for me to do longer sessions because I kind of have the momentum and in my brain is fresh of what I've been doing. But anyways, so I probably won't record for much longer than 6:30 would be maybe the latest. I mean, I'd love to finish by 6. 7 would be like the absolute latest. 6:30 is probably more realistic goal. Okay. All right. So I just need to. I think the heat is good. I think I can just begin. Actually, let me leave that running for a minute. I liked how that old version of this that I did has a sketch that it starts with. What is this? Oh, right. I don't know how I want to do this, but oops. What? Incomplete statement. Oh, I'm missing a end curly bracket. Okay. Okay. Yeah, Guy, that is a bird flocking is an example. Interesting. These are both good. These are both good ideas. I really like. I don't know. I'm stuck on the flower. I also see your point, Guy, about the inheritance concept, but that is well far beyond, I think, where the audience is at the moment. I know I'm a little stubborn here, but I kind of am attached to this idea of a flower. So we'll see. Okay. Now I have this. And I probably will go with bubbles when I actually start to make an example, because that's always worked well for me in the past. The bouncing ball is kind of a pain, and I like the idea of having a bubble. Okay. Bird is nice, though. You're right that there is kind of like fly and nest. You could kind of imagine multiple functions like that. Okay. Also lends itself well towards the inheritance idea that Guy is talking about. Okay, that's off. This is off. Let me get this wire here. I am wearing the same clothes, the same outfit from the functions videos, and I might just like save this and wear it again tomorrow just to kind of make the end seem somewhat seamless, but we'll see. Yeah, exactly. That's my plan. Yeah, that's my plan, is to start with a generic. Okay, so let me talk this through. I mean, maybe there's some way I could reinvent this a little bit, but here's my plan. My plan is to start with the same kind of just general discussion about why do we care about object-oriented programming. Hey, look at this example. Look how there's a ball object. Like, where's all the code? And then move towards talking about the concept of how our programs have data and functionality, and then maybe like think of the scenario of a flower, and then talk about this idea of a flower class versus the actual, flower itself that you would find in your garden, and then from there actually work through the syntax with the sort of bubble example, and then I'll do constructor arguments, making, I might do something where then I'll probably have like two objects. Then I'll do something where like mouse interaction with the object. Then maybe I'll do like collision detection between the objects, a collision, intersection detection between the objects, and then an array of them, and then that will be it, I think. But I do want to end with the confetti. So maybe I'll turn the bubbles into confetti. Yeah, I could just call them particles the whole time, but I think it's kind of fun to have something called a bubble. Like, particle is very computer graphics sciencey. So, but I think at the end I'll be like, let's make one more example to like celebrate the end of this series, and we'll make the little burst of confetti that was Simon's ideas. All right, any thoughts or comments about that before I get going? Check my phone here. Sorry, I'm reading some messages right now while I'm waiting to see if there's any comments. Sounds good. Sounds good. Okay. The only thing that I'm missing is if I'm talking about the functionality of a flower. I mean, certainly in the context of programming, we'd have like a render function. But if I want to be more abstract and not get into that yet, the only thing I can think of is grow. So a flower grows. It blooms. I guess I could have bloom. A flower blooms. grows and then it blooms. Could we do both of those? Anybody have any other ideas for like a second function? Properties is easy because I can think of color, height, number of petals, that kind of thing. Okay. Okay, so first up, does feel which side is dark? It's this side that's a little bit dark, right? That's fine. Could turn this a little bit more. It's fine. I need another light, I think, that I would mount on this pole. Probably might make sense, but anyway. Yeah, I like that. That's why I like the bird thing. I know. I don't know why. I really like the flower. It's like, it's a nice, pretty, soft, colorful thing. And maybe to encourage people to make flowers as opposed to birds, which is fun too, but that's, I don't know how you, anyway, okay. I'm going to say grow and then bloom. I'm going to turn that into 2 separate steps. That's what I'm going to do. Okay, so here we go. Rolling Open Broadcast Studio. Open Broadcast Studio is recording. Rolling, what is this one called? Whiteboard camera. Rolling green screen camera. And I'm noting that the time is 5:21. The green screen camera only records for 30 minutes at a time. So after I'm going for a little bit, I should pause, hit stop, and start again on that. The files are also really big on the camera. So the more I like pause them when I don't need to be recording, the better. I also, I don't know if I have, shoot, let me just see if I have, and of course I should be doing this before I hit record, but here we go, really quickly. Let me just check if I have the very end of what I last did. Part 4, transition grab. Part 3, part 4, I think, is this it? No. So I don't have an export of the function stuff, but the last example I did was functions 2, the lollipop. Oh, which kind of is like a flower. I should have made these flowers. Oh, a lollipop. But then I get into weird, like, what is the functionality? You lick the lollipop. That's not going to work. So we'll go with flowers. But if I could go back in time, I would have made these flowers. Okay, so this is what I did last. This is actually good, though, because I now am thinking about, I want to do things with these and animate them. The way I've written this code is not going to be enough. Object-oriented programming is going to be our path. Okay, let me get Discord back open. Okay. I wish I could remember. Hold on. Let me pause the recording for a second. I would really like to. So that false start, everybody. I just want to go to the last stream and just look at the end. because it really helps me to like watch what I last said. So if I go to YouTube, I'm going to go to Studio, Content, Live.
Oh, it's going to be beautiful. It's a topic that will just bring everything together. It'll help us wrap up this whole intro video series, and we'll just launch you off into the rest of this journey of a lifetime, programming and processing and beyond. But maybe just for a little bit, take a break, stretch, get some fresh air, and practice. But you should probably take a break for yourself, get some fresh air, stretch, move your body around, and also take a little bit of time to practice this idea of functions that return a value. You could try something similar, like converting Fahrenheit to Celsius. Maybe you have your own favorite mathematical equation that you could put into a function that returns a value. Maybe you're thinking of something even more creative that I can't possibly imagine. Give that a try, take a little break, and then we'll be ready for classes and objects. All right, that is good for today.
Okay, I just want to so that I forgot that was not the last thing I did. Where are the lollipops?
Kilometers to miles because...
Oh, okay, there.
I mean, I guess actually I'm just going to fly. I'll probably have this fly in, so I don't know why I'm doing this now. When did I last have the... I don't know why I decided to do this right now. It's like... Sorry, I'm just being silly. So, okay. Forest. Yes, that's exactly what I was going to say. Maybe you can make a delightful forest of... And look, you might end up with something like a delightful forest of lollipops.
It's very uncomfortable.
So give that a try. I know. So give that a try. I know you won't be able to stop yourself. So give that a try. I know it's going to be really hard to pause the video right now because when I come back, I am going to finally explain what this word void means and why the function definitions have return.
All right.
And now it's really just a matter of practicing this. So maybe what you might try to do is define a size variable for the lollipop, so you can also pass that in as an additional parameter. So you can pass it's an argument when you pass it in. So now it's really just a matter of practicing this. If you want an exercise, what I might suggest is adding more parameters to the function definition of lollipop. Maybe you want to add a size parameter so you can pass in.
Okay, I think I got the idea. So I think actually using the lollipops as like a sort of like start here. But let's leave the code and go to here and okay. Let me try this. Actually, it doesn't really matter because I can, sorry everybody. Yeah, okay. Trying again. Rolling OBS. Rolling whiteboard camera. Rolling green screen camera. Let me make sure it's really recording on the whiteboard camera. It is. Let me just write on the whiteboard. Getting some like notifications, but let me write on the whiteboard just so we can make sure the focus is good. Object oriented. Programming. Okay. How is the focus on the camera? Looks good to me as far as I can tell. Okay. All right. 5:30. It could be worse. Could be worse. Could be worse. Okay. Let me get a So just leave this open, and here we go. Just wait for the 20 minutes of me trying to record the first sentence of what I'm going to say. Times like these where I wish I would write a script or something, but I think it's better this way. All right. Hi again. You're amazing that you have made it through. All right. Hi again. I know I say this all the time, but this time I really mean it. This section is the last section. Okay. Hi again. I know I say this a lot, but I really, really mean it this time. This is the last section of this long intro to programming course with processing. And what am I trying to say? Okay. Hi again. Now, I know I say this a lot. Okay. I know I could, but I can't. Okay. Hi again. I know I say this a lot. This time, I really mean it. Here we are in the final section of this very long video. Thank you for still watching all the way through. Hopefully you've taken a lot of breaks. I have no idea how you're watching this, but okay. Okay, I'm gonna get there. Hi again, welcome. Oh, this is a momentous occasion. I know I say this basically every single time I take a break and come back, but this is the most exciting and important section of this whole video. Thank you for sticking around. I mean, it's been hours and hours. For me, it's been actually days of trying to record all this, and we're finally here. I'm finally going to talk about object-oriented programming, classes and objects, and it's going to just revolutionize the way that you think about and are able to organize your code and make processing sketches, hopefully for the rest of time or however long you choose to program in processing or whatever you choose to program in. Okay, there we go. I want to go back to our friends, the lollipops. I kind of want to think of them as flowers, maybe, because that's... Yeah, I did. Or weeks. I mean, to be honest, maybe it isn't the most important, but whatever. I already said that. It's fine. Do I really want to talk about the lollipops? All right, I think I will. All right. Remember this scene, the sun shining down on the lollipops? That doesn't really make any sense. Maybe we should think about those as flowers. Remember this scene, two beautiful flowers growing from the ground, the sun shining down on them. Okay. Remember this scene, the lollipops? Now this is forced. I hate it when it's forced. Okay. Remember this example that I made back in the section on functions? We have these two lovely lollipops and the sun shining down on them. I mean, maybe we should think of them as flowers because it's a little weird to have the sun shining on the lollipops. But that's not the point of what I'm saying. That's not the point of what I'm saying. What I want to talk about is what I want to talk about now is how we think about the elements that live inside a processing sketch. Star is good, by the way, Amr. Okay, I like that. But Functions, learning about functions introduced you to the idea of reusability and modularity. And in fact, we have a modular program broken into parts, and we're able to draw the lollipop twice, reusing the same lollipop function. But if I were to carry this idea forward, if I were to think of these flowers as things that should animate, they should grow from the ground, and they should bloom, and the sun. But if I want to carry this idea forward, and I want to start to have those lollipops or flowers animate, maybe they grow, maybe they bloom. I want to have the sun, maybe the sun sets and then the sun rises. It would be very hard for me to continue this line of thinking with only functions. I need something more. I need something more. Okay. Now, let me go back to another previous example. This is the bouncing ball. Look. This is the bouncing ball. Now, if you look at the code that's actually written there, it will be completely unrecognizable to you. By the end of this section, I hope you will understand all of the parts of this code and how to make your own objects. This is the bouncing ball sketch from the section on conditionals. This is the bouncing ball sketch from the section on condition. What time am I at? Yes, okay. I have to just be mindful of this camera, but that's fine. This is the bouncing ball sketch. This is the bouncing ball sketch from the section on conditionals. Like I'm just saying that over and over again. I have no idea what I'm doing next. Okay. This is the bouncing ball sketch from the section on conditionals. The code is probably completely unrecognizable to you. Why am I having trouble with this part here? This is the bouncing ball sketch from the section on conditionals. The code, the way I've written, is probably unrecognizable to you. But just look at it for a second. Let's just read it. Ball equals new ball. Wait, where's the x? Where's the y? Where's the x speed? Where's the y speed? There is none of that. There is just this idea of a ball. Ball dot update. Ball dot show. Where's the part where I add x speed to x and y speed to y? And I have an if statement to check if the x has reached the edge of the canvas and it turns around. I know I'm not supposed to use canvas, but I like using canvas. It's still a canvas. Window. All right, let me just say that again. I'm just going to have to keep that because I have completely forgotten what I'm doing. Okay. Where's the code where I call stroke and fill and circle? Where's the code where I call stroke and fill and circle to draw the actual bouncing ball? All of that code is actually in a separate tab in processing. Separate tab? What do I even mean? Look at the top. All of that code is actually in an entire other part of this processing sketch, a different tab. I can click here on ball, and suddenly I see those variables, and I see those calls to fill and circle, and all of that logic to move the ball. Now I'm just showing this. Now I'm just showing you all this to give you a taste of the way this program, the way this code looks. Encapsulation. What's the encapsulation, inheritance, and polymorphism? Those are the sort of three main concepts. This code is the embodiment of the first principle of object-oriented programming. This code is the embodiment of the first principle of object-oriented programming, encapsulation. What do I mean by encapsulation? So all of the sketches we've been writing follow a kind of similar format. They've got a setup and draw. What do I mean by encapsulation? So all of the sketches, everything that I've shown you so far, it always has kind of one. What do I mean by encapsulation? So every example that I've written so far, it generally has just one page of code. What do I mean by encapsulation? So every example that I've written so far generally just has one page of code, and it has a setup function and a draw function. At the top of the code are usually many variables, the global variables for the sketch. Another way to think about those variables is that another way to describe those variables is are. A way to describe is. Another way to describe those variables is the data of the sketch. Another way I could describe those variables is the data of the sketch. Then inside setup and inside draw is typically all of the logic of what's happening in the sketch. How are we manipulating the variables? What are we using the variables to do? Are we using the variables to draw things, to test some logic, to perform interaction with a person who's operating the sketch? Many lines of code full of assignment operations, conditional statements, loops, all that stuff. That I might refer to as the functionality of the sketch. That I might refer to as the behavior of the sketch or the functionality of what the code is doing. Let me just pause for a second. Okay, just checking the chat. Amr, that's a good suggestion, but I've pushed forward too far. I will come to that. And it wouldn't actually work with the way I wrote that code right now because the two balls would be identical. So, but regardless, okay. The principle encapsulation refers to the idea of packaging the data and functionality together into one thing. An object. Now, to be clear, even though I'm talking about this in the context of a processing sketch, I'm not talking about taking the entire sketch and putting it into an object. Now, to be clear, even though I'm talking about Now, to be clear, even though I'm talking about a processing sketch, I'm not suggesting that we take the entire processing sketch and package it into an object. A key element here is thinking about what are all the different parts of the processing sketch and how do we divide them up into a collection of different kinds of objects. But for simplicity's sake, if we're starting with a bouncing ball, if I'm starting with a bouncing ball, but for simplicity's sake, the examples that I'm starting with are things like the bouncing ball, where the whole sketch is just one ball. So I'm going to make one ball object, and that's the whole sketch. But keep it in mind, because as we go forward, I might want to have lollipop objects and flower objects. Keep this idea in the back of your mind, because as we move forward, I might have a sketch that has lollipop objects and sunshine objects and all sorts of other kinds of things inside the sketch. I'm not sure how helpful that is. I could cut that out later if that was like just adding to the confusion. My board is so small here. I did not mean to come all the way over here, because now I have to talk about the flower over here. Am I on camera standing here? Not really. I have to really lean in to be on camera. All right. Let's think again about a flower. What is the data? Okay, what are the data of a flower? Well, what are the data of a flower? I mean, we could think of this as, what are the data of the flower? Another way to ask that question might be, what are the properties of a flower? Let's think about a flower. What are the data of a flower? Another way you might, acting, stop acting, just talk. Just check the chat. Yeah, I think that's what I'm doing, Simon. Yes? No? But, okay. What are the data of a flower? Another way that I don't know why I can't get this out. What are the data of a flower? Another way I could ask that question is, what are the properties of a flower? Well, maybe the properties are things like the number of petals. Maybe what color is the flower? What is the height of the stem? I could keep going, obviously, but this is the data. Now I want to ask, what is the functionality of a flower? And again, another way I could think about that is, what is the behavior of a flower? Well, maybe I could come up with things like the flower will grow. Maybe the flower will bloom. And I'm writing those with parentheses because they are functions. These are variables, these are functions. And remember, the idea of object-oriented programming is to take a concept like a flower and package, encapsulate all of its data and functionality into one thing. But there is a really key element that I have not yet described to you. I keep using the word object. Here, I have a marker object. I have a glasses object. I have a shoe object. I'm talking about things in the real world, the physical world that I inhabit, as physical objects. They exist. I can see them, I can touch them, I can operate them. That, this is going to sound weird, is very different than the idea of a marker, the idea of a shoe, the idea of glasses. In object-oriented programming, we have the concept of a class and an object. Right here on the board, this rectangle, this box, is not an actual flower. It is just the description of what it is to be a flower in the world. The concept of a flower is a thing with this data and a thing with this functionality. This is the class. An actual flower itself, I don't have one, sadly. I really should have thought of that in advance. But if I could walk in here and show you a flower, that would be an instance of an object. The class is the template, the source code, if you will, for making an actual instance of an object of the type defined by the class. This is also really key. This is also really key. This is also a key point. Anytime you declare a variable, you need a type and a name for that variable. Maybe there's a score that's a floating point number that has an initial value of 100. When you make a class, when you make a class, when you build the template for an object, you are defining a new data type. It's not a float, it's not an int, it's not a string, it is a flower. This is really exciting because you can start. This is really exciting, and what I want to now show you how to. This is really exciting and is exactly what I want to slowly, step by step, show you all the bits of syntax you need to learn and how to write your own classes and generate your own object instances in your code. All right, how did I do there? I'm gonna do a little pause of recording, and look how it's stuttering now, my goodness. Stop recording. Stop recording. Hopefully this is still recording, that's lucky. Stop recording. Okay, so I got a little into the weeds there beyond where I wanted to. And I was kind of refusing to erase the whiteboard, but I guess good enough. Okay. So how do I want to start this now? I'm going to do the bubble. I mean, first of all, any feedback is welcome, although I don't know if I have any way of going back. I mean, I could kind of go back and say one more thing. Entity. Oh, I like that, Amr. Yes. Yes, that's a very good point. I think for ease here, I'm kind of it's an oversimplification to talk about it as like physical objects, since they're not. Of course, they're not actually physical objects. Okay. So let me close this. Close this. Close this. Ooh, it's raining outside. Okay. God, I have so many sketches open. Now, I remember let me go to website. Just turning a little heater on. Do you guys see the stuttering on YouTube? It's very prevalent and it makes me sad.
Right now, in this very video, we are going to dive into the nuts and bolts and details of object-oriented programming. We're going to look at the syntax for writing an object in our main program, and we're going to look at the syntax for how we define a class, how we define the template, the thing that allows us to make objects. So we have this bouncing ball. I'm sorry about stupid bouncing ball. Not that I'm not sure it's really that much better, but we're going to do something slightly a little bit different. We got a bubble. We're going to think about making bubble objects. Come on, computer.
Okay.
We have a bubble. Here is our little circle. It's floating on the top of the screen. It's the top. This sort of stuff. So what do we have? We wrote this program. It's much like a bouncing ball program. It's just got a bunch of functions. It has display, ascend, top.
Balloon would also work, by the way.
But this is a non-object-oriented program. No, this is a non-object-oriented program. We are going to turn it into an object-oriented program. How are we going to do this? Okay, so first things first, we're going to sort of look at this backwards. Before we can make an object in our code, we've got to define a class. But let's actually look again at the syntax for using objects in our code. Well, we know the general framework. There's setup, and there's draw.
Okay, so I'm just curious. There's the whole weird ES6 stuff in this playlist.
Hello, this is a very exciting moment for me. I don't know if this is an exciting moment for you. This is the video where I am going to talk about...
God, the audio is awful in this.
Using something called, and you might have called it with an X. And this isn't written themselves. When you do that in a while, it has say things like change the code that will run. This is not going well. Whatever it is, if I can think about this thing moving around on the screen as an object, then I can make it through too, and make the code useful. This is also true of object-oriented programming. But one of the first key principles of object-oriented programming is this idea of encapsulation. I want to encapsulate everything that it is to be a certain thing inside of an object. What does it mean to be? And the idea of using it, or if you chose for in as these are functions that are somehow part of the objects. The idea of encapsulation is to encapsulate the idea of data and functionality into an object. So, for example, I had this weird little JavaScript literal.
All right, I don't think I need to watch these. I know what to do. Okay, so because you didn't do the modularity example. I did talk about breaking it up into parts, but anyway, it's fine. Okay, so I think I want to erase the whiteboard. Or do I leave it and just start working on the code? I think I need to write the syntax on the whiteboard for a class. I guess I'll erase it as I go. What time is it? 6 o'clock. So I could just be like, okay, well, that was a good start. Let me come back tomorrow and Sunday and like do the rest. But I think I can get further. I think I can get further. So let me keep going. Weather notification. Flurries. Can I restart the internet? My son is texting me, can I restart the internet? I would prefer if he didn't, because it's going to mess up. Well, he texted me a while ago. I'm not going to answer. I don't know why I'm... Okay, sorry, I was looking at my email, which I shouldn't do. All right, I'm just gonna let's keep moving along here. Okay, I'm gonna record. Rolling OBS. Rolling whiteboard camera. Rolling green screen camera, noting the time as 6:01. So if it is 6:30, I need to make sure I have stopped the recording to restart it by then. Okay. All right. Okay. Okay, I have a confession to make. I'm very tired of the bouncing ball. Let's try something a little bit different. Honestly, something a little bit simpler that will help me focus on the important details about classes and objects. I have a sketch here that I have just made, and it is called a bubble. I'm going to run it, and we have this lovely little circle floating up to the top, and off it goes. In the code, I can see that I have an XY. That is where I am drawing the bubble as a circle, and then I'm manipulating the XY by moving it up by a random amount and also moving it left and right horizontally by a random amount. My goal is to turn this code, my goal is to write a bubble class in order to make a bubble object and then show you how to make another bubble object and another bubble object, all without any additional code. No, that's right. My goal is to write a bubble class from which I can make a bubble object and then another bubble object and another one and just fill the screen with bubbles, all the while only having one set of X and Y's in my code, because of object-oriented programming and encapsulation. Why I'm insisting on having the erasing be as part of this, but okay. Now, I'm going to approach this slightly in reverse. Now, I'm going to approach this kind of in reverse. You can't have the object without the class, the template, so it would make sense to write that template first. But I want to look at what the object code, I want to look at the code for operating the object because it will actually give me the instructions for how to design the class. The variable in my sketch will be of type bubble. I wasn't explicit about this yet, but you'll see when we make, I wasn't explicit about this yet, but you'll see whenever you write a class defining a new data type, that data type should have, I haven't been explicit about this yet, but anytime you write a class defining a new data type, that data type, the convention is for it to start with a capital letter. This allows you to easily differentiate it from just any other variable name. This is a type. It's a type that I'm going to make up, but it is different than an actual variable. The variable should start with a lowercase letter. And it gets really confusing because almost all examples, and I'm about to do the same thing, will call the data type bubble with a capital B, and then the variable bubble with a lowercase b. But let's have a little fun here. Let's have a little fun here and call it something different just to help us differentiate. Let's call it just bub, B-U-B. This is like any other variable declaration. I have the name of my variable, which I've made up, and the type of my variable, which is usually a float, an int, a string. It's a new kind of type that at some point I have to design the bubble class. This is like the flower class here. I'm going to make a bubble one. This is like any other variable. This is like any other variable declaration. I don't know, does anybody have a better suggestion here? Should I just call it bubble? Should I say B, bubble B? Do you like bub? I kind of like bub. It's kind of funny. Pascal case. That's interesting. I did not know that. Okay, nobody has a better idea, so I'm going to keep that. This is like any other variable declaration. I have the name of the variable, bub. It's a little bit of a weird name, but it's what I picked right now. And then I have the type, which is a new type that I'm about to define in a class. The type is bubble. To initialize a new object, there's a new keyword for you to learn. And guess what? That keyword is actually new. Bub should store, it should equal a new bubble object. Yes, this is a little bit redundant, but this is the way of the world. We define a variable of type bubble, and then what do we store in that variable? A new bubble object. And I will get to more about what's really going on here and why we have the keyword new and why are we saying bubble again here? Why are there parentheses here? I'll get to that soon. Presumably, now remember, an object has both data and functionality. So we don't see the data right now. I'll tell you that the data is all being initialized as part of this call to new bubble, but I do want to see the functionality. The functionality, the behaviors of an object are accessed through a new kind of syntax called the dot syntax. I reference the variable bub, and then I can execute any function that is part of the bubble class with the dot. So maybe I'll have dot update. I'll call my function update to update the location and properties of the bubble. I could call it like ascend or float. I probably don't want to call it float because float would be confusing since there's the data type float, but you get the idea. It's the functionality, anything that you might choose to call a particular behavior of a bubble. And then I also want to have another function called show. I could call it render, I could call it display, I could call it draw even, but I'm going to call show, meaning that's the functionality of the bubble that draws itself to the processing window. So this is our goal. I want to take this program that has setup and draw and all these variables, change it to look exactly like this and have it produce the same exact result. Yeah, I'm kind of, it's funny, like I do that a lot. I use the my bubble, my this. That is a nice way of doing it. I do also agree with Simon. It tends to be like confusing because you never actually really do it. But yeah, this is the situation that we're in. It's a nice way of not having it just be called a bubble. My bubble, a bubble, bubble one, I could say. But I'm going to go with bub. It's a little bit weird, but it's what I'm doing right now. Okay. Technically, this is not required because, okay, no, all right, I guess. All right. So now let's talk about how you write the class. A bubble class is yet another block of code. We start with the keyword class to indicate we're about to define a class. Oh, sorry, I saw something go black there, but it doesn't matter. We start with the keyword class to say we're about to define a class. We must specify the name of this class. Again, the convention is to use a capital letter. It'll work if you don't, but it'll make me very uncomfortable. So I really suggest you capitalize the names of your classes. And then we have an open curly bracket and a closed curly bracket. So everything that goes inside those curly brackets is all about defining the data and functionality of the class bubble. What data do we need? Go back and look at the code. All I had was an X and a Y for that particular bubble. So what do we need? If you go look at the sketch I just wrote, the only variables in there were an X and a Y. So I don't need to say that. So what data do we need? Well, this is a very simple sketch. I'm just starting with a bubble as having only two properties, an X and a Y. There we go. Just like I used to define variables at the top of a There we go. Now you might be saying to yourself, oh, I know, these are local variables, right? They're not global. They're not outside of setup and draw. They're local only to the class bubble. Well, that is correct in a way. The term for these is actually instance variables. It's a fancy way for saying these are the properties of any bubble object. Anytime I make a bubble object, there will be an x and a y that is attached to that bubble object. Anytime I make a bubble object, there will be an x and a y that are properties of that bubble object. So now the question becomes, where do I initialize those variables? I could actually just initialize them right here in the same way. I'm like, so now the question is, where do I initialize those variables? Now, I could just say float x equals 100, float y equals 200, the sort of typical way I would initialize a variable. But I'm going to show you something that is going to lead us to more possibilities. You know, I kind of want to skip that for now. What if I don't do the constructor just yet, because it's kind of the confusing thing? Let me come back to that. So Mathieu, I'm going to come do the constructor later. Now, I haven't initialized those variables yet. I'm going to come back to that, put a pin in that. Let's look at how I would define the functionality of the object. Well, guess what? All of that work we did to learn how to define a function, it's exactly that same syntax. The only thing that's different is we define the function inside the bubble class. So instead of there being a setup or a draw or a mouse press or a lollipop or a sunshine function, a sort of global function, if you will, I am putting a function inside the bubble class. And inside those functions is where I can implement my logic. For example, in update, maybe I want to decrease the value of y so the bubble floats up. And I'll make it a random value. Oh, wait, shoot. Ah! I said minus a random negative value. So I could say minus a random positive value, or I could say plus minus a... Let me just do that again. I don't know if this is going to be a continuity issue. I'm just going to do the whole thing again. Maybe in update, I want to decrease the value of y by some random value. Maybe in update, I want to decrease the value of y by some random number so that the bubble floats upward in the processing window. And then maybe in the show function, I want to display the bubble as a circle. With some given hard-coded diameter. But if you're thinking what I'm thinking, it probably would make sense at some point to make this also a property of the bubble. But I'll leave that to later, maybe even as an exercise for you. Boy, this looks awful. What did I do here? I guess there's nothing to do. Ruining it. I should just rewrite it. I'm just going to rewrite that. It won't, this will be a weird, glitchy thing that hopefully nobody will really notice. But somehow I smeared it. Okay, we're almost there. I have pretty much all the pieces. I have the main sketch where setup and draw is, where I am declaring the bubble object, initializing it, and operating it with functions update and show. I've written most of the bubble class, defined what properties are part of the bubble, the data, the instance variables, and I've implemented the functions update and show right here that manipulate the data and use it to do things like draw stuff onto the window. But I missed a really key part, and I left it to the end because it is a little bit confusing and it's the newest aspect of all of this. I never initialized those variables. I never talked about why I say new bubble here. The missing piece is something called the object's constructor. Shoot, let me get a paper towel. Oh, I really want to unbox that Commodore 64. Oh, I ruined this pen. Do I have another one? No one will notice. See, look, I did it again. Smeared it. That's the worst. Oh, Matthew, you're going to have fun with this. A lot of like fast forwarding or cutting or something. Okay. The object's constructor is a special function that's called with the keyword new. When I say new bubble with those parentheses, it executes the code that is inside these curly brackets. The function's name is bubble with a capital B matching the class name. The parentheses are where any arguments would go, and the parentheses are where I might define some parameters, which I'm going to show you in a little while. And then the curly brackets define where the beginning and end of the function is. And what goes in there? Well, lots of things could go in there, but typically speaking, that's where I want to initialize the object's variables. The constructor you can think of as the setup function for a class. What happens at the moment that the object is created? And here, maybe I just want to define the location of the bubble. And there we go. This is it. This is everything. We have all of the syntax for how to write a class, a template. Remember, there will be no object if all you do is write the class. The class is the instructions for what an object should do when you've actually created one by calling new bubble, the name of the class. Then you have that object stored in this variable, and you can operate it with different functions. I'm going to do a really fast stop-start of the recording. I'm pretty sure instance variable is a correct term. Let me just search for that right now real quickly to make sure I didn't like completely make that up. Yeah, I think it's like kind of like a Java term. An instance variable is a variable that's specific to a certain object. It's declared within the curly braces of the class, but outside of any method. Yeah, okay. So I'm definitely right. That is a term that is correct. Whether it's confusing and I should have mentioned it, that's a whole other question, but yeah. All right. It's time to put that code into action. So the question that you're probably wondering is, well, where do you write the class? Just like if I were to add a function to this, a class, like all the other things I've been talking about, is a new block of code, and I actually could put it anywhere. I could put it at the top. I could put it in between setup and draw. I could put it below draw. But something that I like to do, and is somewhat conventional with processing, is to use the feature of the processing editor that has multiple tabs to write your classes in a new tab. It just helps you keep the code nicely organized. So I'm going to go up here and click this down arrow. I'm going to select new tab. I'm going to name the tab. It doesn't have to be the name of the class, but that's going to make things easier to follow and understand. So I'm going to call it bubble. And then now, right here is where I'm going to write the bubble class. I've kind of gone over all of it already, so I'm mostly just going to type it, but I'll try to talk and give you some reminders as I'm typing it out. I'm declaring a class. The name of this class is bubble, and I've got an open and close curly bracket. A bubble has two properties, two variables. A bubble has two properties, an x and a y. And the constructor is a special kind of function. It doesn't have a return type, so I don't have to write void or figure out what it's returning. It's actually returning an object of type bubble, and we don't have to specify that because that's just considered automatically. It's actually returning an object of type bubble, but we don't have to specify that because that's just what constructors do. They construct the bubble object and they return it. I'm going to initialize the variables x and y in there. And then I want to write the functions for the bubble. Update and show. Both of these functions don't return anything, so the return type is void. They also don't have any parameters, so there's nothing between the parentheses. As we move forward and I make a few additional examples, you'll see when, oh, I might want to have a function inside of a class that receives arguments. Oh, I might want to have a function inside a class that returns something. So all of that is possible, but in this basic foundational example, I'm not having any return type or any parameters. What goes in update and show? Well, the nice thing is I actually already have that code written. I want to manipulate the variables in update. So let me take this out and paste it in here. And I want to draw the bubble in show. So let me cut this out and paste it in here. Now again, the names of these functions, update and show, I made those up. It's something that I tend to do a lot with things that are animating. I want to have an update function and a function that draws it. And the fact that I'm putting these statements in one function versus these statements in another, again, these are all personal style choices in the way that I like to organize my code. They're not rules. You might like to write and organize your code in a different way. I wish this would all fit into one screen. Guess if I made the font, why is this console, I can't bring it down any further? Oh, you know what it is? It's because I made that font size so big. Will this let me do it now? No. Yeah, okay, there we go. And there we go. This is the entire code for the bubble class. Unless I made a mistake that I haven't yet discovered, but when I run it, we'll discover if I made a mistake. I don't think I did, though. I guess we'll find out. Now, no longer do I want an X and a Y here in the main part of the program. Instead, I want one variable of type bubble. I'll use my silly variable name, bub, because it's, hey bub, my friend the bubble. And then in setup, I will initialize the bubble. Again, I could write that up here, but I'm just sort of writing things in the longer way just to demonstrate. And then in draw, I want to call update. Again, remember the dot syntax, bub.update. I'm accessing the function update that is part of the class bubble. And then bub.show. Okay, ready everybody? A drum roll, please. We did it! We took that entire sketch. We did it! We took that entire sketch that was not object-oriented and in some short amount of time turned it into a sketch that has a bubble class and a single bubble object. And a single bubble object. One of the things that is really wonderful about this, in the sense that we've made this program modular, we've separated out the different functionality of the bubble into two different functions, is I can do things like comment out a function. This can really, I can do things like comment out just one function that I'm calling on bubble. This can really help with debugging because now if I run it, the bubble isn't moving. You know, again, this is such a simple scenario. There's nothing really going on here, but this ability to be able to turn on and off different pieces of functionality very easily because I've separated them and encapsulated them into the bubble class can be really, really helpful. All right, I have an exercise for you. Why don't you try to take this example and, all right, I have an exercise for you. Actually, I have two exercises for you. You can do both, do one, or just keep watching because I'm going to move on with this to the next step. But one thing I might suggest is find something that you've made previously in processing that was not object-oriented. Could you examine and analyze that code to try to figure out how you would encapsulate the concept of what it is that's in your sketch into a class? So maybe you drew a beautiful flower. Could you make a flower class that has the variables you need for that flower and the functions that you need that are presumably animating and drawing that flower? Exercise number 2. Take a look at my bubble sketch here. Could you take this sketch and add a second bubble? What would you need to do to add a second bubble? Could you add another property to the bubble? What about the size? What about the color? What would it mean to add another property to the bubble? Maybe you add another function to the bubble. Could you add a bounce function? Or could you add a bounce function or some type of check edges function? What do you do when the bubble reaches the top of the window? So give those things a try. When I come back, I am going to show you. So give those things a try. When I come back, I'm going to specifically look at both of those things. I'm going to add some functionality. I'm going to look at making more than one bubble. And that's going to lead me to what is perhaps the most confusing aspect of all of this. I'm going to show you why you might want to include arguments in the constructor, define the constructor with parameters in order to initialize and create your bubble objects. All right, pause recording. So I think that's a good stopping point for today. It's 6:35. I'm going to go and take these clothes I'm wearing and put them to the side so that I can put them back on. So I don't know whether I'll be doing it tomorrow or Sunday or Monday. I really hope I'll be doing it before Monday because I think I probably need 2 more sessions to finish this. I need to do a session where I look at the arguments to a constructor and make multiple bubbles, maybe even then an array of them. Then I need to look at some more interactivity, like with like the mouse, and then maybe having them check collisions with each other. So, but while I could maybe like do a little more for 15 or 20 minutes, I don't think I would get that far with the constructor arguments. So I'm going to start that fresh. I'm sorry that I'm not really good at scheduling these. I'm kind of just seeing what the family is doing and when there's like a window of opportunity for me to come and record more. In an ideal world, I might try to record tomorrow morning-ish, like before. The lighting in here will change a lot, which is make it a little bit wonky. But or I'll probably come back late afternoon, like today, but earlier than 5, 3 or 4. So just stay tuned. Don't schedule around me. Simon, since I know you love to watch, in particular, if you have any conflicts this weekend, you should feel free to let me know. Any other feedback or thoughts before I go? Let me know. Let me start uploading these files. New, okay, processing into a series. By the way, we should have we should start all, I mean, I have a severe advantage in this, but we should have a little contest to see who can guess what the final length is, what the final length of the actual video will be. Sorry, February 17th, objects. And I might actually, maybe I should wear something different if I come here and do this tomorrow morning, because the lighting will be so different. And then I can just be like, I'm back and it's a fresh day or whatever. One thing that's really cool is Jason is making these fun little animated interstitials. So whenever I say when I come back, there's going to be a little animation with a title card that says, function or whatever it is. So I can, if anybody wants to see what some of those look like, I can share them. I'm not seeing any comments from people, so I'm assuming we're all good. I'm going to click end stream and just I'll give it 1 more minute just in case. I wonder if I should get the files off of the camera also. I can't really upload them from home because my connection here is so bad. When I go into NYU, I upload the files. So, but it wouldn't hurt to back them up. Oh no. Did anybody... Was the audio been fine this whole time? Because my mic fell underneath the sweater. Nobody said anything, so I'm just going to assume it's fine. But that would really, it looks fine in terms of the levels. I don't know if you can tell a difference, but I guess I'll have to watch this back. If the audio was a problem, I'll have to redo this. Well, hopefully not. But there's a bunch of you watching this, so I think it was probably fine. I'm going to wait now to see if anyone wants to tell me if they noticed it. Any big change all of a sudden just now. Yeah. By the way, you should never assume that I've got my act together, right? If it's the audio sounds weird. Oh, Dan probably knows that, and I'm probably not hearing the correct audio. That's never the case. That's why I do it this way. Okay. Let me get the memory cards out of the camera. Maybe I can manage to upload these. Audio was good. Okay, great. So I'm not going to worry. I'm not going to worry. I will make sure Mathieu checks them. February 17th, Coding Train recording. I'm just going to copy off of the memory cards just so, even though if I don't upload them to Google Drive, I have those files. And let me go to Untitled, Private, M4 root, clip. And then today is 1, 2, 3, 4 MP4 files. Only another 25 gigabytes. And this is the whiteboard. And then so that's copying. So I'm going to end the stream. You can obviously message me if you want in Discord, but I'm just going to shut the stream off. And I'll see you all tomorrow or Sunday. Hopefully anybody wants to join. Thanks everybody for joining, and hi to Guy, who we haven't seen in a while, and Chris and Kathy and Amr and Simon and anybody else who's watching.